I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIC. Today's presentation is entitled Systems Engineering Challenges for Integrating Software Assurance into Defense Systems Throughout the System Acquisition Lifecycle. My name is Steve Warzala. I am the CSIC Outreach Manager. A few administrative notes before we begin. First, all phones have been muted except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function. And time permitting, your questions will be answered at the end of the session. Today's briefing slides will be posted on our website within a few days. Finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding that DTIC provides enables CSIC to conduct these webinars. It's my pleasure to introduce our presenter for today's webinar, Dr. Kenneth Nidifer. Ken has over 56 years of government, industry, and academic experience in the field of software and systems engineering. He's currently the Director of Strategic Plans for Government Programs at Carnegie Mellon University Software Engineering Institute. Ken has successfully executed positions as a Senior VP at Fidelity Investments, Vice President of the Software and Systems Consortium, Director of Technical Operations Engineering at Northrop Grumman, and he also served as a colonel in the U.S. Air Force. Ken, thanks for joining us. I will turn the presentation over to Dr. Nidifer, and the floor is now yours, Ken.
Thank you very much. My name is Ken Nidifer. As Steve noted, I'm a principal member of the technical staff at the Software Engineering Institute, which is part of Carnegie Mellon University. My discussion today focuses on the systems engineering challenges for integrating software assurance into defense systems throughout the systems acquisition lifecycle. Specifically, the presentation focuses on the Program Manager's Software Assurance Guidebook being developed for the Department of Defense. This presentation was first presented at the Software Assurance Community of Practice meeting in March of this year. The development of the guidebook that we'll be talking about today is sponsored by the Department of Defense Joint Federated Assurance Center. The mission of the JFACT is to promote software and hardware assurance in defense systems acquisition programs, systems, and supporting activities. This presentation will review the JFACT-sponsored effort to provide program managers with a guide for engineering in software assurance into the defense systems during the entire systems acquisition lifecycle. Software assurance is defined as the level of confidence that software functions as intended and is free from vulnerabilities, either intentionally or unintentionally designed or inserted as part of the software throughout the lifecycle. The guidebook is important because PMs need a resource to assist them in dealing with the challenges associated with software assurance. PMs face a considerable number of software assurance challenges, from complex and changing requirements, technology, and agency and shareholder dynamics. There is a basic threat associated with the development and sustainment of software systems, in that a nation state, terrorist, criminal, or rogue developer may be able to gain control of systems or affect mission capabilities. Software vulnerability and exploitation are the root causes of the majority of computer security problems. In fact, software is the target of choice for these hackers. The key issue is that delivered software has latent defects, in part because of human error and the fact that software for even the most simplest components cannot be exhaustively tested. As the size of software exponentially increases in our newer systems to meet mission needs, the interconnectedness of our systems increase, and the defects and vulnerability correspondingly increases. As a result, the attack surface also increases, which represents a significant risk to DoD missions. Additionally, most weapon systems involve embedded and cyber-physical elements for which safety, security, reliability, resilience, and other qualities need to be maintained to meet the mission needs. As a result, there are usually engineering and programmatic trade-offs that a PM must face. The guidebook is a synthesis of knowledge gained from existing engineering practices, recommendations, policies, and mandates that assist PMs in managing software assurance activities over the acquisition lifecycle. It recognizes and attempts to mitigate the fact that key gaps exist in the Program Management Office activities to implement software assurance within their programs. Slide 3, please. This chart provides the Carnegie Mellon University copyright agreement and states that the material has been properly approved for public release. Slide 4, please. In early 2017, a change to the Department of Defense Instruction 5000.02 was made to include a new enclosure on cybersecurity that outlines several actions DoD acquisition program managers should implement to ensure system security and related program security across the acquisition and operational lifecycle. Currently, there is a lack of adequate DoD program manager guidance on ensuring software assurance activities are engineered in throughout the DoD acquisition lifecycle. As a result, the Department of Defense requested that the Software Engineering Institute lead an effort to develop a program manager's guidebook for integrating software assurance activities into the systems acquisition lifecycle, referred from now on as the guidebook. The guidebook supports program managers who must integrate software assurance activities into the acquisition lifecycle. The guidebook discusses program mission threads, threats, threat awareness, and addresses the roles and responsibilities and processes of members of the program office team. It covers software objectives, activities, and work products for each phase of the Department of Defense Integrated Defense Acquisition Technology and Logistics Lifecycle, and provides checklists for consideration of software assurance activities for the phases of the acquisition lifecycle. The guidebook also addresses software assurance activities relative to milestones in the acquisition lifecycle, presents software assurance from a program risk, management, budgeting, schedule, and control perspectives, and describes software assurance statutory, policy, and guidelines. Slide 5, please. The guidebook is being developed in several phases. The activities presented in this chart are completed. The development of the guidebook is following a systems engineering process by first defining the requirements based on the mission and goals established by the project owner and key software assurance community stakeholders. The mission needs and goals were documented in the project plan as part of Phase 1 activities. This followed by Phase 2A, which included the development of requirements and a model architecture that supported the functional and quality requirements. Phase 2B included the development of the architecture structure, which included the development of several components of the guidebook. In Phase 3, a draft version of the guidebook was developed and released in February of 2018, which was really a stretch goal for the project. A little later in the presentation, Phases 4 through 9 will be discussed. Slide 6, please. Software assurance spans the entire Department of Defense integrated defense acquisition technology and logistics lifecycle, and the guidebook aligns with these activities and milestones for each lifecycle phase. An abbreviated conceptual graphic of the acquisition lifecycle, which highlights the software assurance activities and milestones, is presented on this slide. The graphic represents 3 levels of systems engineering foci of software assurance as part of the acquisition lifecycle. The first and upper level of the chart, represented by the individual boxes, presents the software assurance activities linked to the phases and milestones of the acquisition lifecycle. The second layer presents the lifecycle phases and associated milestones. Key takeaway from the software assurance is that systems engineering activity is required so that the software engineering component can be integrated in throughout the acquisition lifecycle. It is also important to note that the acquisition lifecycle will continue to be updated as new systems and systems assurance concepts of operations evolve and newer, mature technologies become available. That said, the need for software assurance to be engineered in throughout the lifecycle will not change. Slide 7, please. The goal of the guidebook is to provide software assurance guidance in a structured context necessary for the program managers to make appropriate trade-offs and decisions relative to ensuring that their system software meets the software assurance objectives. The term software assurance is a noun, not a verb. It is the level of confidence that software functions as intended and is free from vulnerabilities, either intentionally or unintentionally designed or inserted as part of the software throughout the lifecycle. By continuing to innovate and evolve software assurance best practices and integrating these activities in the software assurance systems and software engineering of the weapon systems, program teams can reduce vulnerabilities and weaknesses in the development software so that when they are deployed, systems are more resilient to attacks. To achieve this goal, the guidebook is aligned on 4 anchor points. First is the enclosure 14 of the instruction 5000.02. Second is the DAU software course, which is under development, called CLE 081. Third is the DoD Integrated Defense Acquisition Technology and Logistics Lifecycle. And fourth is the Deputy Assistant Secretary of Defense for Software Engineering, Software Assurance Concept of Operation. The context of the guidebook is that of a weapon system program office is formed and a program manager is implementing the software assurance activities and is attempting to meet the software assurance goal for acquisition phases, activities, and milestones. Slide 8. The guidebook has 12 objectives. 6 are listed here. Due to time limitations, I will address the first 3. Objective 1, support program managers and their teams in successfully meeting their program software assurance goal. Under that, software assurance, again, is the level of confidence that the software functions as intended and is free from vulnerabilities. Depending on the mission and goals of the program of interest, the program manager is responsible to establish the goal for the appropriate level of confidence. For example, the guidebook addresses the logical question a PM might ask: where do I find software assurance requirements and objectives on my program, and why does it matter? The overall goal of a PM is for their system and interfacing systems to be accessible to achieve the mission success. Today's weapon systems are highly complex and largely driven by software. The complexity of the software and its latent weaknesses leaves systems vulnerable to the introduction of weaknesses through the acquisition lifecycle. Software exploited weaknesses can impact the successful execution of one or more of the mission threads. Guidebook also addresses how PMs go through specifying the important common weakness enumeration from a community list of common software weaknesses, the common vulnerabilities and exposures from a list of common names for publicly known cybersecurity vulnerabilities, the common attack pattern enumeration and classification from a comprehensive dictionary and classification taxonomy of known attacks that can be used by analysts, developers, testers, and educators to advance community understanding and enhance defenses. And lastly, countermeasures designed in the RFPs. For example, in the statement of work, the specifications, the contractor data requirements list. Objective 2, identify how PMs can determine program mission risk and threats associated with their software. A threat is a circumstance or event with the potential to adversely impact agency operations, including mission, functions, image, and reputation. Agency assets or individuals through an information system by unauthorized access, disclosure, modification, and information, or denial of service. The program manager, assisted by supporting organizations, has a significant amount of information available, which is addressed in the guidebook to help establish the software assurance goal and requirements for their program. Objective 3, describe software assurance engineering activities and its relationship to other security activities. Software is the foundation of most systems comprising our nation's military power. Program managers face intense software assurance challenges from complex and changing requirements, technology, and agency and stakeholder dynamics, in part due to the growing role of software in enabling functionality in DoD systems and the associated latent defects associated with the software. The program manager's objective is mission success. Thus, the achievement of software assurance is an important goal. It must include systems security engineering activities integrated into the systems acquisition lifecycle. As a result, the guidebook addresses the software engineering and program team activities and associated milestones. The other guidebook goals are, as listed, provide PMs with software assurance policy and guidance, associate software assurance and products in each phase of the acquisition lifecycle, and provide a PM checklist to support decision-making associated with software assurance activities and products in each phase of the software acquisition lifecycle. Slide 9, please. As discussed, the guidebook has 12 objectives. The other 6 goals are listed here. I will address the first 3. Goal 7, associate software assurance activities and products in support of major milestones in the acquisition lifecycle. The guidebook provides software assurance guidance in a structured context necessary for each PM to make appropriate trade-offs and decisions relative to ensuring that their system reaches the level of confidence for software assurance required by the program stakeholders at each phase and milestone of the integrated defense acquisition lifecycle. The guidebook addresses how the PM identifies and is informed by results of activities and products generated in support of each phase and milestone in the acquisition lifecycle. Goal 8, Provide a PM checklist for software assurance activities in support of major milestones in the acquisition lifecycle. For example, a PM is provided relative to the activities and products that need to be addressed in support of each phase and at key milestones. For example, at the material solution analysis phase, the guidebook asks the PM if the software team has addressed the mission and the goals of the system relative to software assurance objective. If there is a question, the guidebook points to applicable documentation to address it. Goal 9, familiarize the program team members with their respective software assurance roles and how those roles relate to other program team security roles. PMs are responsible for meeting the software assurance goal for their system. In meeting that goal, PMs should view the software assurance activities included cyber security and information assurance activities as ongoing program activities to achieve the level of confidence needed for mission success, that software functions as intended and is free from vulnerabilities. This approach includes a variety of key team members who have various roles for each program, depending on the program scope. The guidebook addresses the roles and responsibilities for the program team for their respective system and how their roles and responsibilities interrelate in order to achieve mission success. Other guidebook goals are providing the PMs with measuring, budgeting, and schedule information for successfully managing and controlling their software assurance processes, identifying contract language that supports the achievement of the program software assurance objective, and providing the program team with additional resources for obtaining software assurance information and assurance. Slide 10, please. This figure presented on this slide provides a view of the software assurance concept of operation for a typical system. I realize this chart is somewhat of an eye chart, and apologize for that. We will be breaking this chart down in terms of components, as we proceed. First, a few words about its relevance. Due to the importance of activities associated with software assurance and the large number of stakeholders' invested interest, a large number of policies and guidance documents have been created. Unfortunately, the vocabulary used by the different stakeholders can be confusing for those not deeply involved in software assurance, and the activities can overlap. As a result, PMs are challenged with respect to what to focus on and what to accomplish. The principal objective is to provide the PM with an operational view of software assurance activities across the acquisition lifecycle. This graphic presented on this chart was developed by Bradley Lanford of Agility Corporation in support of the Department of Defense. And it provides the operational and organizing view of the guidebook's content. The arrows represent data flows that are located with respect to the activities. The figures represent data repositories or documents. The workflow is a graphic in time sequence starting with mission dependency identification and critical analysis to select the top important common weakness enumerations for the system. In terms, slide 11, please. In terms of the guidebook's structure, the draft guidebook contains currently 21 chapters and 5 suggested appendices. Chapter 1 provides an introduction to the guidebook. including its goals, objectives, contacts, background, and benefit. It also addresses the logical question the PM could ask. How does the software relate to program security considerations? What am I responsible for? Chapter 1 points to Appendix 1, which largely answers that question, where Appendix 1 is the enclosure 14 of the DoD Instruction 5000.02, which provides the PM responsibilities across the lifecycle. Chapter 2 of the guidebook discusses the program mission threats, and awareness. It addresses the logical question the PM could ask: where do I find software assurance potential impacts relative to my program, and why does it matter? The red box in the graphic presents the context diagram for how a PM specifies the common weakness enumerations, the common vulnerability and exposures, the common attack patterns and enumeration and classifications, and countermeasures designated for their system. A significant part of these activities are accomplished prior to the formation of the program office. A key program's system security officer function is to make sure that the program mission threats, threat awareness, and associated important common weakness enumerations, common vulnerabilities and exposure, common attack patterns and enumeration are identified, documented, and socialized within the program. Slide 12, please. Chapter 3 addresses the roles, responsibilities, and processes of a represented set of members of the program team. It addresses the logical question for the PM to ask: what are the roles of the program team members in the accomplishment of the program software assurance and other security goals and objectives? The context is part of the ConOps diagram, which is circled in red in this graphic. Many programs and project roles may have shared duties. For example, the Program Office Protection Lead, the POPL, may also act as the System Security Engineer. The objective is to provide PMs an understanding of the software assurance workforce responsibilities and how they can objectively make appropriate planning and trade-off decisions. Chapter 3 highlights software assurance functions and contributions by each member of the program team and associated processes. Although the principal focus of the Program Office software assurance roles, responsibilities, and processes, this chapter also highlights inputs to the software knowledge base, the key program documents, such as the systems engineering plan and the program protection plan. Slide 13, please. As mentioned, the Chapter 3 also addresses the individual members of the program team which contribute to software assurance. This slide provides representative members of the security program team for a weapons system. Most of the team are part of what we call the Software Assurance Working Group, which I will discuss next. The program is concerned with how to effectively and efficiently identify risk and mitigate them so that mission success is achieved within the program constraints. This is a significant challenge given the perspectives of the different members of the program team, acquisition policy and guidance, and that many of the security issues are interrelated. Although not a panacea, it is highly recommended given the complexity and functional relationships and deliverables of the system security engineer that the PM establish a charter a software security working group with management responsibility for all system security functions within a program management office. The System Security Working Group may also be referred to as the Program Protection Integration Team or the System Security Engineering Working Group. Slide 14, please. This chapter highlights the next 6 chapters, which focus on software assurance objective activities and work products in each phase of the integrated defense acquisition technology and logistics lifecycle management system. It addresses the logical question for a PM to ask: what specific activities should be taken to achieve software assurance goals in each phase of the acquisition lifecycle? The guidebook provides the PM with a frame of reference relative to the cybersecurity guidance in Enclosure 14 of 5000.02, and that the software assurance activities and products are aligned with each phase within the DoD integrated defense system. That said, depending on the software assurance goals established for the program, these software assurance activities can be tailored to meet the software assurance program goal for each phase. Chapter 10 also provides the PM with a detailed checklist that addresses this PM question in each phase of the acquisition lifecycle. Slide 15, please. Chapter 11 introduces the next 6 chapters, which focus on software assurance activities that support milestone activities at each phase of the integrated defense acquisition lifecycle. It addresses the logical question the PM could ask: what specific activities should occur to achieve the program's assurance objectives at each milestone? The guidebook provides the PM with a frame of reference relative to the guidance in Enclosure 14 of DoD 5000.02, and that software assurance activities and products are aligned with the phases and milestones within the integrated lifecycle. That said, depending on the software assurance goals established for the program, these software assurance activities can be tailored to meet the program goal for each phase of the lifecycle. Next slide, please. Chapter 18 also provides the PM with a detailed checklist for addressing each question. Chapter 19 provides guidance on how a program manager identifies the adequacy of systems engineering products, security controls, policies, and procedures. It addresses the logical question for a PM to ask: how does a program manager plan and control program activities to achieve the program's software assurance goal? This chapter also discusses the cyber integrator. Meeting their software assurance goal in the software DoD acquisition of defense systems is a top concern of both the program manager and DoD as a whole. The question arises: what can be done to help the Department of Defense program managers in total meet this challenge? An emerging concept is to establish a cyber integrator at the program executive office level to help address cybersecurity risk in the DoD acquisition programs. The purpose of the cyber integrator is to lead cybersecurity efforts within the program executive office. This includes effectively integrating cybersecurity across all functional domains and acting as a principal advisor to the program manager and the PMO on cybersecurity matters. Slide 17, please. Chapter 20 provides definitions of key terms relative to this report and references for where other terms can be found. Most of these definitions come from the National Initiative for Cybersecurity Careers and Studies, Glossary, the management of the Department of Homeland Security, and NIST, National Institute for Science and Technology, internal report 7298, and other glossary and key information security terms that are found in government documents. The objective of this glossary are to enable clearer communication and common understanding of cybersecurity terms through use of plain English and annotation in the definitions. It addresses the logical question for PM to ask, what do software assurance and related software terms mean? That said, the cybersecurity field is rich in terminology, and the program manager is well advised to seek clarification from other sources. Chapter 21 provides a list of software assurance statutes, regulations, and guidelines. It addresses the logical question the PM to ask, what software assurance governance documents exist, and what is their relative importance? There are currently 5 principal appendices in consideration. Slide 18, please. As mentioned, the guidebook is developing in several phases. The development of the guidebook follows the systems engineering process. This chart presents the last 6 phases of the guidebook's development. After completion of the guidebook's architecture and draft version of the guidebook in phase 3, which had several reviews by the stakeholders, the guidebook was released to the software assurance community at large as part of phase 4 DT&E effort for a comprehensive review that ended on 30 April. The guidebook is now being updated for comments in phase 5. As far as the OT&E, phase 6 is a harmonization effort of the Software Assurance Developers Guide, which is also currently under development, and the Software Assurance course, which is also under development by the Defense University, which with a target date of completion of 30 August. I should mention that the Software Assurance Developers Guide is also being developed by the Software Engineering Institute. The guidebook will then, after it completes this phase, be turned over to the DoD sponsor in phase 7 for additional OT&E activities, such as executive level staffing and updates and operational testing, which will be talked about near the end of this presentation. Phase 8 and other phases include prototype activities and collected comments from the user communities. For example, the Defense Acquisition University and the Cybersecurity and Information Systems Analysis Center are sponsoring on 8/7 an experiment to evaluate the software assurance guidebooks, programming, and development, and their intent to fill gaps in the current assurance effort. During this experiment, a notional system will be provided, and participants will be asked to review the effectiveness of the key lifecycle assurance decisions that meet the operational and security objectives. Phase 9 includes a formal release. The key objective is to have the guidebook as a key takeaway from the Defense Acquisition course on software assurance. Slide 19, please. In summary, this webinar focuses on current government effort to provide the government program managers with a guidebook for engineering in software assurance into the defense systems during the entire systems acquisition lifecycle. I trust you came away with the importance of the guidebook and how it's being constructed. Along the way, several reviews were held. In each of those reviews, we addressed certain aspects of the slide, of the guidebook. For example, is the guidebook headed in the right direction? Is the guidebook correct, consistent, and complete? Again, I'd like to remind you this work is funded and supported by the Department of Defense, which manages the DoD Joint Federated Assurance Center. Mission of the Assurance Center is to promote software and hardware assurance in defense programs, systems, and activities. I'm going to turn this over now to Steve, who will talk a little bit about our experiment that's coming up. So you can skip the next two charts there, Steve.
Okay, thanks, Ken. Yeah, so I'm going to turn this over to one of my colleagues here at the CSIAC, Cully Patch. We've been conducting some different cyber experiments in collaboration with the Defense Acquisition University, and we're planning to do another one coming up later this summer. This is in support of the JFAC and working with Ken at the SEI. And like I said, I'm going to turn it over to Cully, who's actually going to be one of the main facilitators at the experiment, and he can provide you with more details on this experiment. Here, Cully.
Hi, my name is Cully Patch. I'm one of the cyber analysts here at the CSIAC. Just to give you a quick explanation, as part of the idea of trying to bring people together of different functions and get them in a room and start discussing issues and coming out with real tangible solutions to hard problems, we've developed these workshops of about 15 folks of all different functions represented in the actual thing from engineering to sustainment, and get them in a room and start talking about things. And we call it the skin in the game workshops. And the idea is to approach tough problems like this, where you have lots of moving parts in the process. Not only you're trying to build the product yourself, but you're also trying to make sure that it's cyber assured. And so, one we did last year, we've been working with the Defense Acquisition University. And last year we did a similar one that you'll see on the slide there, where there's a link to the report, where we went and I tried to walk through a process using a maintenance laptop, and we walked through different parts and milestones of the acquisition cycle with the about 10, 15 people from, as I said, software engineers to system engineers to sustainment folks in the room, so that we could walk through the process and capture what's working well, what's not working well, but especially what kind of gaps that existed. And the overall idea was to evaluate the DAU overall course, where to make sure that key cybersecurity curriculum was addressed, and if there were gaps that they could be filled. And it only took a day, half a day, to do some actually wrap-ups on the next day. But that's the idea behind these workshops, is to be able to have these one-dayers, get lots of people of different functions together to be able to address the issues at hand, but then also being able to capture that and to come out into a form of how we can actually go from these sometimes intangible, how are we going to handle all this complexity, to this is how we can get a start. And like I said, on the bottom, you'll see the link to last year's. And lastly, we also want to make sure that if someone is interested in doing this, we are currently selecting candidates for our 7 August event. So you'll find some contact information if you're interested. It is a one-day event on the 7th of August at IDA and the Institute for Defense Analysis down in D.C. With that, I'll turn it over back to Steve.
Thanks, Cully. Yeah, so like Cully said, we're going to be doing this experiment, and basically, we're going to pick a kind of an exemplar system. It could actually be a real world system, but the plan is to the goal is to evaluate the software assurance guidebook and get some feedback on that. It's not to evaluate the system itself. It's the guidebook and see where there's see if there's any gaps or places that we need to shore up. So that will be the purpose of the workshop. And so you can see, like Cully said, it's going to be on the 7th of August, and we're looking for we want to get a good representation, a cross-functional representation. So it's just not the software development folks. Where there's a lot of different parts that go into making the system work, and so we want to try to get a variety of folks to different perspective viewpoints. We'd like to get have them get their say in that. So as Cully said, we are in the process of trying to identify candidates and try to put together this core team. And as far as the number of participants, it will vary. It is a workshop. We want people to be actively participating. So it may be in the order of 30 to 40 people, something in that ballpark, and we may be splitting them up into groups. So we may have three teams, say maybe 3 teams of 10 to 12 people, something on that nature, and have them work on different parts of the process, different aspects. And so, like I said, if anybody wants more info or might be interested in participating as we're doing this evaluation, there's my contact is on the slide, and you can send me an email, and we'll we can work that out. So, all right, I think that concludes the presentation portion. We got to a little late start today, but we'll. And I haven't had a chance to look at what kind of questions have come in, but we'll see if we can hit a couple. If we don't get a chance to answer all the questions, yes, go ahead.
Go ahead. Well, I can see the questions, just to let you know, and I was going to pick off 3 before we close, but I wanted to.
Go ahead.
You were asking for them to be. The questions to be sent in. Is that correct?
Yeah. The attendee. We've had the folks, submitting a number of questions from attendee chat. So if you've that's great, Ken. If you've had a chance to take a look at that, and if you've got a few you'd like to answer. So the one thing, I'll ask you to do is to state the question and then give the answer.
Thank you very much. Please do. My mentor of many years ago, who taught me so much, is Jack Ring, and Jack has been very active in asking a lot of questions. So I will let me tackle one that he asked, and many of them are actually fairly deep, and so we'll take those later because he's just a great systems engineer. Jack asked, does a normal SCI review process result in 0 defects? And I thought that was extremely good from 2 points. First of all, we always have this disclaimer on all of our products that that's not true. There may be defects in our products. We hope not. We work very hard not to have them. But in terms of cybersecurity, if I would flip that, and I hope he doesn't mind, the challenge we have is that all of our software will continue to have defects in terms of development for several reasons, but the two primary that I see is humans make errors, and the second, we can't effectively test all the logical paths in our software. So what we're really trying to promote is, because there is a relationship between defects and vulnerabilities that we have done research on and shown to be true, that we want to remove as many of those defects up front as possible. Today, most of our tools and our processes and our methods focus on the time that we have the software and are doing testing on that software. And so we have a very good set of tools out there. Well, I wouldn't say they're great, but they are good relative to this area in the life cycle. We want to push that back into the front where we have more tools and methods, and that we are being more diligent with respect to how we engineer in our activities throughout the life cycle, so that we reduce the number of defects, whether we produce them in the initial development phase or we continuously produce those in the ongoing sustainment phase. And what we're seeing today is more of a DevOps concept where, although we develop the initial, we continuously develop throughout the sustainment period. So this is very important to us, that we get the front end correct in terms of removal of defects. And I think that's a good discussion for Jack and I have probably offline in our work. The second one,
Ken,
yes.
can I just kind of a follow-up question on that? So,
Sure.
What's your take? What's your perspective on formal methods, formal proofs? I know some folks are working on like certified security by design type of concepts. Do you have thoughts on bringing that process in?
So all the comments now are not sanctioned by the SCI necessarily, but I will give you my view on it. I think
Sure.
those are very good. In other words, we should promote those. And at the SCI, we are developing capability in that area. The hard trade-off for a program manager is that he's only got so much schedule and so much budget to do the work. And what we need is a realization that when we enter these systems in development, that application of those processes and those methods will take time. And as we move more towards a agile environment in terms of, well, maybe 80% of the requirements when we deliver something is okay, this becomes even more important, because we still need that time, whether we're doing the initial development or we're developing a capability in the field. And today that realization is hard because the customer wants it as fast as they can get it, and the PM, regardless if they're in the initial development or they're in the sustainment phase, are put under a lot of pressure in terms of delivering a capability, but may not go through the appropriate assurance checks. So the simple answer is yes. The hard part is, like most things, is the implementation of good overall technology and processes that we have to date. However, I will also say we have very limited tools and capabilities in the front end of the life cycle today in comparison that we have in test. So test is a lot of times almost too late to capture a problem, especially if you catch it in operational test and evaluation, because it's going to cost you almost 100 times more or better. We've estimated around 300 times more to remove that vulnerability, as if we couldn't catch that earlier in the life cycle. And I don't know if that answers your question, but the answer is yes. We just need to do more. Maybe it's a short,
that's great
response. Right.
Great. Thanks. Appreciate that.
I was, one of the questions from a colleague of mine, Mike Bandor, and his comment is the DoD acquisition lifecycle still looks a lot like the waterfall. However, it is software methodology agnostic. That's true the way I presented it. The argument I would make is that as we go more towards different types of life cycles, and as we explore additional ones in terms of getting capability out there faster, you're still going to go through the basic phases, although those phases may overlap. So the what Mike you're saying is correct. It's just the fact that the assurance capabilities are more probably process driven, so more assurance case activities. It was not possible for me within the limitation of the guidebook to list all the assured cases for each of the values. However, the National Defense Industrial Association has produced a software assurance case work, which I'd be pleased to send you, that shows the assurance cases independent of what phase or methodology that you're using at the time. So point taken, it was just easier to explain it this way, but I would certainly not teach it this way, if that makes sense. And I'm just reading down here, try to get different people, not helping me too much. This is one from John James. It's a long one, but I'll read it and see if I can answer it. The software assurance techniques are great, but ignore the vulnerabilities associated with the composition of cyber. What he means by that is the networks and computers, components and physical weapon system components. While software components can be, and I'm having trouble with my cursor, while some software components can be formally proven to be correct, the components of cyber and physical security are not subject to such proofs. That is a correct statement. The JFACT looks at both hardware and software. What we're finding is that more of the hardware is becoming software enabled. So if I take a field programmable gate array, I see a board, which is hardware, but that board can be software enabled depending upon, it is software enabled depending upon the function that it's supposed to carry out. So it can carry out multiple functions, and that hardware doesn't have to change. The argument I'm making, I think, is that although it's correct that, in fact, very correct, that we need to look at the hardware part of it. In fact, Microsoft or Intel keeps proving it because their chips contain defects that lead to vulnerabilities. We can do so much, probably, I don't want to say more because both of them are important. We need to, probably as you point out, we need to treat them equally. And in the JFACT, we do, which is the Cyber Assurance Center. This presentation is on software. We could have made one on hardware. Now, as far as networks are concerned, we also agree with you, and we see that the software network, or the networks, are becoming more software enabled, meaning the fact that we can control, for example, what packets flow down the line, how to optimize the networks for different traffics, in fact, how to cut off certain things so that we do not have issues associated with network loading or blocking of our networks. So I would say that from an assurance point of view, we are looking at the hardware components that exist within a system, and we're also looking at the networks. So that's just a response to your question. This particular effort was targeted at the software. We could do others. So at that, I will take any questions. In fact, I would appreciate if you could send them to me, and I'll contact you and we'll talk through, because I want to make sure that what we've written and what we're trying to do meets an impact that we need to have within the community that are developing our systems today, so that they're less vulnerable to attack. And we have, if you look at the F-35, for example, and put that down at the lower end of an XY curve, we have a fairly good feeling by looking at commercial products that we're going to continue this exponential growth in the number of lines of code to meet the capabilities that we need in the future. So if we, much like the earlier question I think that Jack asked, if we don't get it addressed today, the view for tomorrow doesn't look that very much encouraging, because we're putting more and more defects and vulnerabilities out on our systems. And obviously, that's not a good thing in terms of mission success. So I'll turn it back over to you, Steve.
Okay, thank you, Ken. Appreciate you fielding a few of those questions. I'll just make Ken, just make one note. On our CSIAC website, we have different technology forums, and we have tech forums for both cybersecurity and software engineering, which obviously the software assurance kind of bridges those two technical domains. You know, if you would like to answer, you know, more of the questions that came in at a later time, if you're up to it, you know, we could post those on our tech forums in order to share the information with the other members of our community. I just wanted to you know, make mention of that if that's something you're up for. But okay, great. And you know, also I want to thank you for taking the time to put together this presentation and provide this webinar today and share your information and expertise with us. We're very grateful that you're you know, we're willing to do that, and I think this shared software is a very important, critical topic, and you know, the more we can get the bugs and vulnerabilities out of the software, you know, the safer, you know, the whole nation will be. So you know, it's very, very important work that's being conducted, and appreciate your efforts.
Thank you.
Yeah, I'd just like to thank everyone for joining us today, and we look forward to hopefully seeing you at our next webinar, and I'd like to wish everybody a good day. So thank you and take care. Bye now.
Bye now.